Hey Cosmic Explorers, I'm Jack.
And I'm Aluna.
And this is the Watery World. On this channel, we're diving deep into water's incredible story.
And it's way crazier than you think,
From its birth in exploding stars,
to how it shaped human empires.
what's the water is the universe's greatest adventure?
So ready to have your mind blown?
Then let's make a splash. Water, one of the most vital ingredients for life. But have you ever wondered where it comes from? Not just on Earth, but in the universe itself. Surprisingly, water was born in the depths of space, long before our planet even existed. To understand its origins, we have to journey back billions of years, to the very birth of the elements.
Wait, water was born in space? That's incredible. So it's older than Earth itself?
In the beginning, the universe was a chaotic sea of energy and fundamental particles. As it expanded and cooled, the first elements emerged, primarily hydrogen and helium. These elements went on to form the first stars, which would later become the factories of heavier elements. Water, as we know it, is made of 2 hydrogen atoms and 1 oxygen atom. Hydrogen was abundant from the start, but oxygen didn't exist yet. It had to be created inside the cores of massive stars through nuclear fusion. As these stars aged and exploded in dramatic supernovae, they scattered oxygen into space, allowing it to mix with the hydrogen that was already present. This set the stage for the formation of water.
So stars are like cosmic factories, creating the ingredients for water? That's mind-blowing.
In the frigid regions of space, far from the heat of stars, oxygen atoms begin to interact with hydrogen molecules, H2. These collisions lead to chemical reactions that form water, H2O. But in space, water doesn't form as a liquid. It
Emerges as tiny ice particles, coating dust grains that float through interstellar clouds.
The process is slow, taking thousands of years for a single layer of ice to form. But over time, these icy dust grains accumulate more material, eventually becoming part of asteroids, comets, and even forming planets. Scientists have detected vast reservoirs of water vapor in star-forming regions, proving that water is a fundamental component of the cosmos. Even newly forming solar systems contain water, meaning that planets born within them have the potential to inherit this essential
Molecule.
So water in space is like cosmic snowflakes? That's so poetic.
Water isn't unique to Earth. Observations from telescopes like Hubble and James Webb have revealed water in distant galaxies, surrounding young stars, and even floating freely in the cold void of space. This discovery has massive implications, not only for understanding the origins of our own water, but also for the search for life beyond Earth. If water is so common in space, could life be as well? One thing is certain: water is not just a product of Earth, but a cosmic traveler, formed in the heart of space itself.
If water is everywhere, does that mean life could be everywhere too? That's a thrilling thought.
water, the very thing that makes life possible. Our oceans, rivers, and even the water in our bodies all share a cosmic origin. But how did water get to Earth? Was it here from the very beginning, or did it come from space? To find the answer, we have to travel back more than 4.5 billion years to the chaotic birth of our planet.
So Earth wasn't born with water? It had to be delivered? That's wild.
In its earliest days, Earth was nothing like the blue planet we know today. It was a scorching, barren world, constantly bombarded by asteroids and bathed in the intense heat of the newborn sun. Any water that may have existed on the surface would have been vaporized instantly. So if Earth started off dry, where did all the water come from? Scientists have explored 2 leading theories, one suggesting that water was delivered from space, and another proposing that it was here all along.
Wait, so Earth was like a desert planet before water arrived? That's hard to imagine.
One of the most widely accepted theories is that water was delivered by asteroids and comets. In the early solar system, countless icy bodies roamed the vastness of space. Some of these objects, rich in frozen water, collided with Earth, releasing their precious cargo. During a period known as the Late Heavy Bombardment, around 4 billion years ago, our planet was pummeled by these cosmic travelers. Each impact delivered water, slowly accumulating over millions of years to form Earth's first oceans. But was it only comets and asteroids that brought water? Not necessarily. Recent studies suggest that Earth's water might have an even deeper origin.
So Earth's water could be a mix of space rocks and something else? That's fascinating.
Another theory suggests that Earth had water from the very beginning, trapped deep within its rocks. As the planet formed, water molecules bound to minerals inside the young Earth's mantle. Over time, volcanic eruptions released this water as steam, which condensed and fell as rain, gradually filling Earth's oceans. This theory explains why Earth's water has a unique chemical fingerprint, slightly different from that of comets. It suggests that at least some of our water didn't come from space, but from deep within our own planet.
So Earth might have been hiding its own water all along? That's like a cosmic secret.
Over millions of years, as the planet cooled, water began to collect in low-lying areas, forming the first oceans. These waters set the stage for life to emerge, turning Earth from a barren rock into a thriving blue world. Today, about 71% of Earth's surface is covered in water, but its journey to our planet is still a mystery we continue to explore. So, the next time you drink a glass of water, remember, you could be drinking molecules that have been on Earth for billions of years. Or perhaps even traveled from the depths of space.
That's so cool. Every sip of water is like a taste of cosmic history.
Water. It's the foundation of all life as we know it. But have you ever wondered, how did life actually begin in water? What role did this simple molecule play in transforming a lifeless Earth into a planet teeming with organisms? To understand this, we must travel back 3.8 to 4 billion years, to a time when Earth was still young and chaotic, yet on the verge of something extraordinary.
So water didn't just support life, it helped create it? That's amazing.
In its infancy, Earth was a hostile place. Volcanoes erupted constantly, releasing gases like carbon dioxide, methane, and ammonia into the atmosphere. Intense lightning storms flashed across the sky, and the surface was bombarded by asteroids.
But amidst this chaos, something crucial was happening. Water was accumulating. Whether it arrived from asteroids and comets or emerged from deep within the planet, Earth's first oceans began to take shape. And within these waters, the first
ingredients of life were about to be assembled.
It's like Earth was a chaotic lab, and water was the key ingredient for life.
Water is special for many reasons. It dissolves a wide range of substances, making it the perfect medium for chemical reactions. It also provides a stable environment, protecting fragile molecules from extreme temperature changes. In these ancient, simple molecules like hydrogen, carbon, nitrogen, and oxygen began to interact. Some of these molecules formed amino acids, the building blocks of proteins. Others combined into lipids, which eventually led to the formation of cell membranes. But how did these molecules transform into life?
So water was like a cosmic mixing bowl for life's ingredients? That's incredible.
One of the most fascinating theories about the origin of life points to hydrothermal vents deep in the ocean. These vents, located along the seafloor, release superheated water filled with minerals and energy-rich chemicals.
Here, in the darkness, the first self-replicating molecules may have formed. Molecules capable of copying themselves and evolving over time. These molecules, possibly RNA, carried the first instructions for life. Over millions of years, they
combined to form more complex structures, eventually leading to the first single-celled organisms. Another possibility is that life began in shallow pools on land, where water evaporated and concentrated organic molecules, speeding up the chemical
reactions necessary for life to emerge.
Once life began, water remained essential. It allowed cells to grow, divide, and adapt. Over billions of years, life evolved from single-celled microbes to multicellular organisms, eventually giving rise to the incredible biodiversity we see
today. Even now, every living thing depends on water, from the tiniest bacteria to the largest whales. Without it, life as we know it would not exist.
Water is like the thread that connects all life on Earth. That's so beautiful.
Water wasn't just a passive ingredient. It was an active catalyst for life's creation. It provided the environment, the protection, and the medium for the chemistry that led to biology. And if water played such a key role on Earth, could
it also spark life elsewhere in the universe? With vast oceans hidden beneath the ice of moons like Europa and Enceladus, and water vapor found on distant exoplanets, the search for extraterrestrial life is only just beginning. One thing is certain. Where
there is water, the potential for life follows.
So, water isn't just Earth's gift, it's the universe's recipe for life. That's mind-blowing.
Water. It can flow, it can freeze, and it can reshape entire landscapes. Throughout Earth's history, water hasn't just been a life giver, it has also been a world changer. For millions of years, Earth has experienced dramatic ice ages, where vast sheets of ice covered the land. These frozen periods have shaped mountains, carved valleys, and even influenced the rise and fall of civilizations. But what causes an ice age? And how does water play a role in these extreme climate shifts? Let's journey back in time to uncover the story of water and the ice ages.
Ice ages sound so dramatic. How did water turn Earth into a frozen world?
An ice age is a period when global temperatures drop, causing massive glaciers to expand across continents. These ice ages last for thousands to millions of years and reshape the planet as water freezes, melts, and moves. But not all of Earth's
history has been frozen. Scientists believe that over the past 2.4 billion years, Earth has gone through at least 5 major ice ages, each lasting for millions of years. One of the most extreme was Snowball Earth, a period when almost the
entire planet was frozen solid around 700 million years ago. But what triggers these icy periods?
Wait, the whole planet was frozen? That's like something out of a sci-fi movie.
Ice ages don't just happen randomly. They are influenced by Earth's orbit, volcanic activity, and greenhouse gases. Changes in Earth's orbit. The way Earth tilts and moves around the sun affects how much sunlight reaches the planet. When less sunlight hits the poles, ice sheets grow. Volcanic activity. Large volcanic eruptions release dust and gases into the atmosphere, blocking sunlight and cooling the planet. Carbon dioxide levels. When CO2 levels drop, less heat
is trapped in the atmosphere, leading to colder temperatures and expanding glaciers. Once an ice age begins, it locks water into massive ice sheets, lowering sea levels and reshaping landscapes. But what happens when ice takes over?
So Earth's orbit and volcanoes can trigger ice ages? That's so cool, and a little scary.
During an ice age, water turns to ice, but it doesn't just sit still, it moves. Glaciers act like bulldozers, carving deep valleys and shaping mountain ranges. As ice sheets grow, sea levels drop, exposing land bridges that allow animals
and early humans to migrate. When ice ages end, melting glaciers release water, creating lakes, rivers, and even changing ocean currents.
Some of the world's most famous landscapes, like the Great Lakes in North America and the fjords of Norway, were carved by melting glaciers from the last ice age. But these icy periods didn't just shape the land, they also influenced the course of life itself.
So glaciers are like Earth's sculptors? That's amazing.
The most recent ice age began around 2.6 million years ago and ended just 11,000 years ago. It was during this time that early humans evolved and adapted to survive in extreme conditions. As ice sheets advanced, humans followed animals like mammoths
and bison, using land bridges, like the Bering Strait, to migrate from Asia to North America. When the Ice Age ended, glaciers melted, flooding valleys and creating new rivers. This sudden warming allowed civilizations to develop, marking the Imonsis beginning of agriculture and human settlements.
So humans survived ice ages and even thrived after they ended? That's incredible resilience.
Technically, we are still in an ice age today, but in a warmer interglacial period. Scientists predict that another ice age could happen in the distant future, depending on changes in Earth's climate. But right now, human activities are increasing, global temperatures causing glaciers to melt at an alarming rate. The question is, will we see another ice age, or are we heading into a completely different climate era? One thing is certain, water, whether frozen or flowing, will always shape the future of our planet.
So water is still shaping Earth's future even today? That's a powerful thought.
Water. It's not just the key to life, It's the foundation of civilization itself. The first humans were nomads, constantly moving in search of food and water. But everything changed when they discovered that settling near rivers meant survival,
growth, and the birth of society. How did water shape the rise of the first civilizations? Let's travel back over 5,000 years to see how rivers turned scattered tribes into powerful empires.
So rivers were like the lifeblood of early civilizations? That's fascinating.
For early humans, water was more than just something to drink. It was the key to food, transportation, and trade. Instead of wandering for survival, people began settling along riverbanks, where they could farm the land, raise animals, and store food. This shift, known as the Neolithic Revolution, marked the beginning of civilization. Permanent settlements turned into villages, and villages into cities, but only where water was abundant.
So water was the first step toward building cities? That's amazing.
4 of the world's first great civilizations emerged along major rivers. Mesopotamia, the land between 2 rivers, Tigris and Euphrates rivers, modern Iraq, known as the cradle of civilization. Mesopotamia saw the rise of the Sumerians, who built irrigation canals to control water flow. They invented writing, cuneiform, to record crop storage and trade. Ancient Egypt, the gift of the Nile, Nile River, Egypt. The Nile flooded predictably, depositing fertile soil, allowing Egyptians to grow wheat and barley. Egyptians built massive canals, reservoirs, and the first water clocks. Indus Valley Civilization, masters of water management, Indus River, modern Pakistan and India. Cities like Harappa and Mohenjo-Daro had advanced drainage systems and public baths. They were among the first to use wells and reservoirs for clean water. Ancient China, the power of the Yellow River, China. Known as China's sorrow due to its unpredictable floods, but also the source of rich farmland. The Chinese developed dams and dikes to control flooding, shaping their empire. Each of these civilizations depended on water not just for farming, but for trade, religion, and survival.
So water wasn't just for survival, it shaped culture, religion, and even technology. That's incredible.
Water also enabled transportation and trade. Rivers became highways, connecting distant regions. This allowed civilizations to exchange goods, ideas, and culture, leading to technological and artistic advancements. Religions, too, were deeply tied to water. The Nile was seen as a gift from the gods. The Ganges was considered sacred, and Mesopotamians built ziggurats near rivers, believing they connected Earth to the heavens.
While water could create civilizations, its scarcity could also destroy them. The Indus Valley Civilization mysteriously declined, possibly due to climate change and shifting river patterns. Mesopotamian cities fell due to droughts, and in some
cases, overuse of water led to salinization, making the land infertile. Even today, access to water remains a crucial factor in the survival and success of nations.
So water isn't just a resource. It's the key to survival and power? That's a powerful lesson.
From the dawn of civilization to modern cities, water has remained the foundation of human progress. It shaped the world's greatest cultures, influenced wars and trade, and continues to determine the fate of nations. As we face new water challenges, climate change, pollution, and scarcity, history reminds us that water isn't just a resource. It's the very lifeblood of civilization.
Water is the thread that connects all of human history. That's so profound.
Water. It sustains life, shapes landscapes, and holds deep spiritual meaning. Across cultures and civilizations, water has been seen as divine, mystical, and even the source of creation itself. From the flood myths of Mesopotamia to the sacred rivers of Hinduism, water has played a central role in mythology and religion for thousands of years. But why is water so sacred? Let's dive into the spiritual significance of water across history.
Water is sacred? That's so intriguing. How did it become so important in religion?
Many ancient religions believed that the world was born from water. In Hindu mythology, the universe emerged from the cosmic ocean, and the god Vishnu floated on a serpent in the vast waters before creation began. In Egyptian mythology, the world started as a great, endless sea called Nun, from which all life arose. In Norse mythology, the first being, Ymir, was formed from the melting ice of a primordial void. In these stories, water is not just life-giving, it is the beginning of everything.
So, water isn't just part of creation, it's the source of everything? That's so poetic.
Certain rivers and bodies of water are considered sacred and are believed to hold spiritual power. The Ganges River in India is worshipped as a goddess and is believed to cleanse sins and bring salvation. The Jordan River in Christianity is where Jesus was baptized, making it a site of spiritual renewal. In Shintoism, sacred springs and waterfalls are seen as places where spirits, or kami, reside. For many cultures, bathing in holy water is a form of purification, both physically and spiritually.
So water isn't just physical, it's a bridge to the divine. That's so beautiful.
Water is often seen as both a giver and a destroyer of life. Many cultures have flood myths, where gods use water to cleanse the world and start anew. In Mesopotamian mythology, the Epic of Gilgamesh tells of a great flood sent by the gods, similar to the story of Noah's Ark in the Bible. The ancient Chinese flood myth speaks of the hero Yu the Great, who saved his people by controlling floodwaters. In Mayan mythology, a great flood wiped out the first version of humanity, before the gods created humans from maize. These myths reflect how ancient people saw water as both a force of destruction and a path to rebirth.
So water isn't just life-giving, it's also a force of renewal. That's so powerful.
Even today, water plays a vital role in religious ceremonies. In Christianity, baptism symbolizes cleansing of sins and spiritual rebirth. In Islam, wudu, ritual washing, is performed before prayer, signifying purification. In Buddhism, water is often used in rituals to symbolize peace and the flow of life. Whether for blessing, purification, or connection to the divine, water remains a key part of spiritual traditions.
So water is still sacred today? That's so meaningful.
Throughout history, water has been more than just a necessity. It has been a symbol of purity, power, and transformation. From creation myths to sacred rituals, every culture has seen water as something divine. Even today, we continue to seek out water for peace, healing, and spiritual connection.
Water connects us to something greater. That's so profound.
Oh, water. It has always been essential for life. But humans didn't just rely on natural rivers and rain. They learned to control, move, and store water, shaping the course of civilization itself. From the first irrigation systems to massive aqueducts, the story of water engineering is one of human ingenuity and survival. Let's travel back thousands of years to see how ancient engineers tamed water for the first time.
So humans didn't just adapt to water, they mastered it? That's incredible.
Before engineering, early humans depended entirely on rainfall. But in Mesopotamia, around 6,000 years ago, farmers learned how to redirect water from the Tigris and Euphrates rivers using canals and ditches. This simple but revolutionary idea, irrigation, allowed people to grow crops even in dry seasons, leading to food surpluses, population growth, and the rise of cities. Egyptians took irrigation even further. They built basins and dikes to capture the annual Nile floods, storing water for later use. This method helped Egypt flourish as one of the world's greatest civilizations. But controlling water wasn't just about farming, it was also about survival.
So irrigation was the first step toward building civilizations? That's amazing.
In places where rivers weren't nearby, civilizations had to dig wells to access underground water. The earliest wells, found in the Indus Valley Civilization, modern Pakistan and India, date back over 5,000 years. But one of the most impressive water innovations came from the Romans, the aqueduct. The Romans built massive stone aqueducts to transport water over long distances, supplying cities, fountains, and even public baths. Some of these structures, like the Pont de Gare in France, still stand today, an incredible testament to ancient engineering. But before the Romans, another civilization had already mastered underground water transport, the Persians.
So aqueducts were like ancient water highways? That's so cool.
In ancient Persia,
modern Iran, where surface water was scarce, engineers developed the Qanat system, a network of underground tunnels that transported water from mountains to dry cities and farmlands. This innovation allowed civilizations to thrive in harsh desert climates for thousands of years, and some Qanats are still in use today. As civilizations expanded, so did their need for water storage and flood control.
So Qanats were like secret water tunnels? That's so clever.
Dams weren't just a modern invention. The oldest known dam, the Sad El Kafara in Egypt, was built over 4,000 years ago. Though it later collapsed, it marked the beginning of human attempts to control flooding. Other ancient cultures built
even more sophisticated dams. The Marib Dam in Yemen, built around 750 BCE, stored water for irrigation. The Romans created advanced reservoirs to ensure a stable water supply during droughts. Dams and reservoirs didn't just store water, they also prevented disasters and ensured stability for growing civilizations.
So dams were like ancient water banks? That's so fascinating.
From the first irrigation canals to grand aqueducts and dams, water engineering transformed human history. Without it, cities wouldn't have grown, agriculture wouldn't have flourished, and civilization as we know it wouldn't exist. Even today, we rely on modern dams, pipelines, and desalination plants to keep our world running. The innovations of the past paved the way for the future, proving that mastering water has always been one of humanity's greatest achievements.
So water engineering is the foundation of human progress? That's so inspiring.
Water. It has built civilizations, sustained empires, and fueled human progress. But what happens when the water runs out? History has shown that the same rivers and reservoirs that gave rise to powerful empires could also lead to their downfall.
From Mesopotamia to the Maya, the lack of water has been a silent but deadly force behind the collapse of great societies. Let's explore how water shaped the rise and the fall of empires.
So water isn't just life-giving, it can also take life away? That's so dramatic.
One of the world's first great civilizations, Mesopotamia, flourished between the Tigris and Euphrates rivers. The Sumerians, Babylonians, and Assyrians built irrigation canals to control water and grow crops.
But over centuries, their success became their downfall. Over-irrigation caused salt to build up in the soil, making the land infertile. Droughts worsened the crisis, and by 1700 BCE, once thriving cities began to collapse. Without enough food and water, Mesopotamian civilizations weakened, making them vulnerable to invasions. The mighty empire that once controlled the rivers became history.
So even the greatest civilizations can fall without water? That's so tragic.
The Indus Valley Civilization, modern-day Pakistan and India, was one of the most advanced of its time, with planned cities, drainage systems, and wells. But around 1900 BCE, it mysteriously declined. Scientists believe that the Sarasvati River,
which sustained them, dried up due to climate shifts. Without water for drinking, farming, or trade, cities like Harappa and Mohenjo-Daro were abandoned. A once great civilization simply disappeared, swallowed by the sands of time.
The Maya built a vast empire in Mesoamerica, constructing massive pyramids and cities deep in the rainforests. But by 900 CE, many of their cities were mysteriously abandoned. Archaeologists have found evidence of a century-long drought. Without enough rainfall to fill their reservoirs, the Maya struggled to grow food. Starvation, wars over resources, and internal conflict followed. Water, or the lack of it, turned their once thriving empire into a ghost of the past.
So even the mighty Maya couldn't survive without water? That's so sad.
The Roman Empire mastered water engineering, building 11 aqueducts that supplied over 1 million people with fresh water. But as Rome expanded, it relied too much on its vast network of infrastructure. When the empire began to weaken, invasions, neglect, and political chaos led to the destruction of aqueducts. Without a steady water supply, cities fell into disease and decay. By 476 CE, the once great Roman Empire had collapsed, marking the end of an era.
So even Rome couldn't survive without water? That's so shocking.
From Mesopotamia to Rome, history has proven that no empire is immune to water crises. Whether through drought, mismanagement, or climate change, civilizations that failed to protect their water eventually collapsed. Today, as modern cities face water shortages and climate challenges, history serves as a warning. Those who control water control their future.
So water is the key to power and survival? That's so powerful.
So we've traced water's journey from cosmic dust to Earth's oceans. But here's the mind-blowing part. 2.
This story isn't over. Right now, 600 million miles away.
There's an entire alien ocean hiding beneath this ice, and NASA's going there.
Will we find extraterrestrial life? Is this where Earth's water really came from?
Drip, drop, don't miss it!